So there's an application of the chain rule. You know, people often wonder where the name chain rule comes from. I was just wondering about that myself. Is it because it chains you down? There's a chain. Is it because it chains you down? Is it like a chain fence? I think I've decided what it is. It's because by using it, you burst the chains of differentiation, and you can differentiate many more functions using it. So when you want to think of the chain rule, just think of that chain there. It lets you burst free.
I want to share the most beautiful equation in math with you, okay? So actually, this is literally, if you search Google, the most beautiful equation in math, you will find it. So this thing, I might need to use a little bit of the board. I'll just write this pi. We already know what pi is, right? There's another number in math, which is called I. This is the square root of -1. So somehow I is equal to the square root of -1, which you're not allowed to do. There's no way you can multiply two numbers together and get a -1. Well, there is if you allow what are called complex numbers or imaginary numbers. So that's this I. You can multiply those two together. You can get an even more crazy number. Not only something that doesn't end, but it's not even a real number. But there's another number in math also, and that number is called E. And E appears on a lot of these scientific calculators. E is another number which is just like pi in the sense that it's transcendental, it doesn't stop anywhere, and also there isn't a very nice way to express what it is. So this one goes by 2.71828 and so on. Actually, this number is also quite impressive. It's 1828, 1828, 45, 90, 45, and more digits beyond there. Okay, so a bunch of nice numbers. But this E actually comes also somewhere else in mathematics. Even though I told you this doesn't have any nice repeating decimal or even terminating decimal, with E, you can get E by saying, suppose I have a box of chocolates with 100 chocolates, and I drop them all on the ground, and I tried to put them all back in. This is like these nice chocolates where everything's different, right?
Yeah.
You can ask like, what's the probability that every chocolate went back in the wrong spot? And that probability becomes very close to 1 over E. That's this, and the more chocolates you have, the closer it is to this. Anyway, 3 crazy numbers. It turns out that if you take E and raise it to that, then I can finish the equation with 2 more numbers. Like the most basic numbers in math are 1 and 0. And this is true. So what's going on here is I've just put together 3 completely ridiculous numbers, and they together make -1. For all of the mess that was here, it has all come back in together right here. And this has a name. It's called Euler's identity. And it is actually the most beautiful equation in math because it combines all of these different constants together.
I think in mathematics, writing is probably more central than it is to other fields, and that's because of the nature of the discipline, which is centered on proof, argumentation, and perspective. Convincing people and making them understand is central to mathematics, and it's also the difficulty of writing mathematics which makes it very important. And as a result, probably it's the only subject where elegance of the writing is central to how we see the subject. One of the most famous books in mathematics is called Proofs from the Book. It's one of these concepts from the mathematician Paul Erdős, where he collected proofs and arguments that were so beautiful they would be in God's book. And I think the idea of things being able to be in God's book is something peculiar to mathematics. So there's an idea, if you hear a proof, then that is so beautiful, then you'd say it's from the book, and there's been collections of such things. And the reason that's so important is because mathematics is not just about finding out what's true and telling people what is true. You want to know why it's true, and you need to convince them that it's true, and also why, in retrospect, it's obviously true. So as a result, the greatest mathematicians have tended to be, although not always, the greatest writers. And what absolutely is true is that really terrible writers have really hurt themselves as mathematicians. If you have a fantastic idea and no one understands you, it doesn't count. If you have a fantastic idea and you don't get across why it's so beautiful, it doesn't count. So writing mathematics is central for that reason. And it's central for a second, somewhat surprising reason, because once you have an idea, you have to write it down. And when you write it down, clearly, concisely, and convincingly, that's when you find out where the flaws in your thinking actually are. It's in the revision process that really you actually learn some of the most important mathematics. When you find a gap in your argument and you realize that that is where the heart really is, and that takes you back to days or weeks of further thinking, that's where the real mathematics happens.